In an earlier video, we proved that P and Q implies R is logically equivalent to P implies Q implies R. We used a truth table to prove it. In this video, we're going to prove the same thing in a different way. We're going to use rules of algebra in propositional logic. One of those we developed in the previous video, which is that OR is what I called associative. What this means is if I have a formula that looks like A or B or C, then that's equivalent to this formula, A or B or C. So where I put the brackets doesn't matter. Another rule that I'm going to use is what I'll call the implies rule. Which is that A implies B is logically equivalent to not A or B. So anytime I see an implies, I can rewrite it as not the first thing or the second thing. And finally, I'm going to use one of De Morgan's laws, which is that not A and B, if I have a not outside the brackets, then that's logically equivalent to a not on each of them, not A, and then an or in the middle, not A or not B. So I can apply the not to both of the things in the brackets as long as I change the and to an or. Let's use these rules to solve this problem. The way I'm going to do this is to start with P and Q implies R. Then each step, what I'm going to do is make a substitution of one thing to something that's equivalent to that thing. The first step here I'm going to make is that I have something implies something else. So if I say that A is this P and Q and B is the R, then the implies rule says I can replace the A implies B with a not A or B, so not the first thing or the second thing. This is logically equivalent to not the first thing or the second thing. Now I have something that looks like De Morgan's law. I have a not on the outside of the brackets and an and inside the brackets. So De Morgan's law says that I can rewrite this part as not P or not Q. And that's or R. So I've rewritten part of this formula with something that I know is equivalent to that part. And therefore, by substitution, the whole of this line is equivalent to the whole of this line. The next step I'm going to apply is that I have two ORs, and one of them is inside brackets, but the fact that OR is associative tells me that I can put the brackets the other way around. I can write not P or not Q or R. And these are equivalent by this rule that says OR is associative. The next step I have is I have a not Q or R, and I want a Q implies R. But the implies rule tells me not the first thing or the second thing is equivalent to the first thing implies the second thing. There's one more step for me to do, which is get this P implies instead of the not P or. But I can apply the implies rule again. I have something on the left which is not of something. In this case, it's not P. And then it's or another thing. So I have not the first thing or the second thing. And that's equivalent to the first thing implies the second thing. So this is equivalent to the first thing implies the second thing. And this shows that because each of these lines is equivalent to the previous line and equivalent to the next line, therefore this first line is equivalent to the last line. And that's what I wanted to show.